Let's see. All right. All right, everybody. If you're there, go ahead and put in the live chat that you can hear us. If not, let me know. I'm not seeing it come up yet on my YouTube. Let's see. There we go. All right, and we got Greg Johnston. Wonderful, wonderful. All right, hello everybody. Thank you so much for joining us today. I am Dan Bigman, GPR professor from LearnGPR.com, and I am super excited today to have Greg Johnston from Sensors and Software. Sensors and Software is a manufacturer up in Canada. He's a colleague. He's certainly becoming a friend, and is actually is one of my GPR professors. You know, so he's taught me now quite a bit. And I'm very lucky to have him, and we're all lucky to have him on right now. So again, if you can hear us, you know, make sure you pop into the live chat and let us know that you can hear us, and that is, you know, that it's streaming through. But we're going to go ahead and get started, as this will, you know, certainly be archived onto our YouTube channel, youtube.com/LearnGPR, and you know, this is kind of what I like to call the GPR hot seat. Okay, it's kind of a segment, you know, that we do not as often, you know, that I'd like to do yet, but I'd love to get your all, you know, feedback if it's something that you like and that you get value from. If you get value from it, if you want me to do more interviews, then click the like button, click the thumbs up button. You know, the more that you guys click it, the more I'll know that you actually want these kinds of this kind of content, and I'll bring you more. And if you have anybody who you want us to interview, then go ahead. So I'm going to jump, you know, put it in the comments below. I'm going to jump right into it then. I'm going to start talking right to Greg about his background. So Greg, I know you've been in it a while, right? You've kind of worked, and I think for Sensors and Software a while. I think your background was literally in geophysics. But why don't you give us a little bit of your background, kind of how you got into geophysics, how you got involved with sensors and software, and kind of what has your career been like, you know, since then.
All right. Okay, thanks. The first thing I'd start off with, I'll say I'm Canadian, so remember that. And I may accidentally say some Canadianisms during this, so I apologize if you don't understand everything I'm saying, but let me know. So I was the geeky kid who loved rocks and volcanoes as a kid, so geophysics kind of became a natural thing when I started to go to university. So I have my bachelor's in geophysics. I never went beyond that. I probably, in hindsight, I wish I had have, but never got that opportunity. So I started off after I got my bachelor's, like a lot of people, I started off in the oil industry. So in Canada, you move out west and you live in Calgary and you work in the oil industry. So that's what I did for a few years. And I worked for a company called Texaco that some people will remember. And later I worked with and a few years later, family reasons brought me back to Ontario, which is where I grew up. And I wanted to stay in geophysics, but it was fairly challenging in Ontario. But I totally lucked out, and I would admit that. And I found a job with this small company, about 5 people, called Sensors and Software, which was a manufacturer of ground penetrating radar systems. And they brought me on as a computer programmer. Now the sound is getting really horrible. Okay, yeah.
All right. Well, let me see if I can go ahead and fix that for a second.
Okay. No, it's better now. So
better now?
Yeah. So when I started with Sensors and Software in the early '90s, I'd never actually used GPR. I never saw it in school, anything like that. But when I looked at the data, I realized, hey, this is a lot like seismic data. The only thing that's different is with GPR, you use nanoseconds rather than milliseconds in the oil industry, and the scales are you're in a few feet rather than miles. And so I kind of told them that, yeah, I think I can handle this GPR stuff, and that's how I got started. And as you say, I've been with sensors now this is my 25th year actually with Sensors and Software.
All right, well, that's a while. And I'm going to go ahead and actually ask you a question. I'm going to force you to say a Canadianism, because when we had met last time, you said one, and I had no idea what it meant, and I may get this wrong. But you said something along the lines of, I don't know, a dog's breakfast, Something about a dog's breakfast. So go ahead. What is that, and what does that mean? I know it has nothing to do with GPR, but it's still something that has haunted me since we have since the last meeting that we've had. I tried to figure it out myself, and I couldn't do it. So go ahead and let us all in on this Canadianism.
I actually remember pretty vividly the first time I used that to an American audience. I was teaching this course in the U.S. somewhere, and I said, we were looking at the GPR data, and I said, it's like, and I looked at the class, and every single person was looking at me like, what did he just say? What does that mean? It's actually a British thing. It comes to Canada through Britain, and my understanding of the phrase is that it's just, you can imagine a dog kind of has a sloppy mess for his breakfast, and when he eats it, stuff gets all over the place. So I end up saying that about ground penetrating radar data sometimes.
No,
so that's what it looks like.
That's funny. That does make a lot of sense. I mean, so one thing that's big and core to our whole training system at Learn GPR is, I try to show people real world, right? I mean, I've seen other folks. Certainly, if you look at academic journals, certainly if you look at some other training videos out there, people love showing really good-looking data. You go onto LinkedIn, and you constantly find the best-looking data that I've ever seen, right? In my whole feed, it's like everybody gets the most wonderful data, apparently, except for me. I know that's not the truth, right? I know that in reality, we all get some messy data, right? Like a dog's breakfast, I guess. And so that's something that I stress, right? And that when we teach, we make sure to show people data sets that get pretty ugly sometimes, because that's just it's real life. And so I think that actually does make a lot of sense. It's clearly related. It is messy, and certainly I've had some very, very messy GPR data. Okay, so you said that when you started there, there were 5 people. That's unbelievable to me now, considering how large Sensors and Software has grown. And I know that you guys were there at pretty much the outset of the commercial kind of explosion of GPR right onto the scene. I know that prior to some of the other manufacturers, obviously there were a couple of folks in some academic positions and some laboratories making their own GPR. Tell us a little bit about kind of the origin of the technology and how, what was it like at that point, because I know a lot of people who are babied now, right, who complain about, their data consoles and, how they have to get off, the data from their console to it. I know you guys actually now have it where almost, I think if you're wirelessly in, that you can kind of, push JPEG images and reports to your cell phone.
That's right.
But I was in a recent GPR boot camp. We just did this a couple weeks back in Atlanta. It's a 2-day intensive course. And so everybody watching, check out, learngpr.com to find the next dates. But when I was doing that, I was talking about when iOmega drives used to have to be plugged in to the console. The iOmega drive had to be taken out, and we would, every day we'd do it because we were so nervous that there was going to be something happening. That's nothing compared to one thing that you showed me the last time we were there. Tell the folks watching now, how did some, GPR professionals have to get, or number one, record and kind of get their data off of their instruments back when you started at Sensors and Software, 5 people 25 years ago?
Dan, you are so young. iOmega drives. Those were amazing at the time, actually.
Right, it's all relative. It's all relative.
Well, I'm young too, in that really when I started, we were using I have heard the stories. Certainly the Peter Annan, who's the CEO of our company, has photos and stories about using GPR in the early days. And if you look at, we have this on our website as well, some images that show early GPR systems from the 1970s. And you're using reel-to-reel tapes to record analog data. And he was saying the reel-to-reel tapes were like 200 pounds. And then you needed 300 watts to run the thing.
Oh my
and
gosh.
so you had half a ton of equipment out there to try to collect the data. And then, of course, something would fail. You'd end up spending half a day getting it fixed, and then you'd collect a bit more data, and then it would fail again. So one of the big innovations when Sensors and Software was being developed and they were starting to work on these more man-portable systems to get GPR into these more remote areas. one of the big innovations, and I think that this is something you laughed about when you were up, we started to use the Sony Walkman.
Yeah.
The Sony Walkman playing a cassette tape. And so we started to record the analog signal onto Sony Walkman cassette tapes. And you could actually, Peter describes listening to the GPR signal. So you'd hear this, and then when there was a reflection, you'd hear the tone change. And so you'd listen and, you know, find bedrock surfaces and stuff by listening.
Yeah.
So it's sort of fascinating.
Yeah, you know, that's wild. I think a lot of people who are probably going to hop onto this and watch it are in utility locating. And, you know, even some of that now still, it's almost listening. Like, yes, you have your, you know, your meter right in front of you, but it, you know, it's that sound that you're trying to null out to get that peak. You know, this is stuff, you know, but understanding that versus how they're using GPR now, but to think about that's kind of how GPR was, you know, then in a way, like, you know, Peter, and you know, being able to kind of hear the spikes and the sounds is pretty, pretty unbelievable. And it's really amazing, you know, how far we've come and how seamless, you know, GPR really is to use now. You know, with the interfaces and the consoles, the data loggers, and then the, you know, ability to export it with ease and process data, you know, after the fact, has come such a tremendous way. You know, even now, like one of the features, again, that is new, I think, to Echo Project, you can correct me if I'm wrong, but, you know, where you can hook the GPS in and everything's coded, and you just export it, and you can time slice down from just your GPS coded locations and the GPR data you collect, and kind of just spit that out as a series of depth slices, you know, down. So it's pretty amazing, you know, how it went from cassette tapes and listening, right, to kind of this exportation into that. You know,
the other thing,
interesting stuff, huh?
You realize as well. I mean, GPS wasn't accurate until the mid 1990s, right? It was a U.S. military. It was used for the military. It was used in the first Gulf. You know, them putting bombs down chimneys in Baghdad and stuff.
Yep.
And people are going, this is incredible.
Yeah.
But at the time, it was military. It was military based, and only they could have that sort of accuracy.
Yep.
And it was President Clinton, I think, who eventually, I forget what the term is, but they were scattering the signal a little bit on purpose, so that it wasn't as accurate for the average person. And they got rid of that in the late 90s or mid to late 90s. And then that started to open up all these possibilities, certainly for GPR as well.
Yeah, and I would say, even though, you know, hyper accurate GPS, you know, for the consumer market, for like utility locators, is almost still being rolled out, you know, because you get a lot of folks now who don't have accurate GPS units but are doing GPR work, and it's kind of still a plus minus, you know, 1 meter, 3 meters, 5 meters, and I think it's kind of a trend that's still continuing on. So this is a great actually transition, you know, into the next phase of it, which is, you know, what's the current state, right, of technology, and what has changed as far as the technology, you know, from then till now? What are some of the things that you think are let's say the 3 most dramatic shifts from the early days until now? And then a second part of that is, how has the user base of GPR changed from then till now? Because I think that's even more dramatic almost than the technology.
Oh yeah, yeah. Well, the user base has changed dramatically, as you said. I mean, in the early days when I was doing this, anybody I talked to who was a customer was a geophysicist. They were a physicist, an electrical engineer, you know, maybe advanced scientist of some sort. But now, as you mentioned, the field's broadened dramatically. So now we're getting archaeologists, CSI investigators, you know, biologists who are looking at you know, biomass in the subsurface, right up to the more standard stuff, utility locators, search and rescue people, and now even ski resorts. I mean, ski resorts are using GPR to measure snow thickness and things like that. So we've dealt with in the last 25 years, it's just dramatically different. And one of the things I really like about my job is I love the fact that when I talk to somebody at a conference or on the phone or by email, I never know who I'm going to talk to. Whether it's somebody looking for utilities or whether it's going to be somebody looking for Noah's Ark. And I've had that phone call. And one of my personal favorites was a call from a biologist who was looking for burrows for an endangered tortoise.
Huh.
And he wanted to use, I heard about this technology called GPR. Could this be something I could use to trace out where the burrows are to try to count the population of these tortoises? And I was like, that was something at the time I never thought of in a million years. It totally came out of left field. And I realized, yeah, you know what? In principle, thinking about this, there's no reason why GPR couldn't image that. And in fact, the other thing that's changed as well is, the people who we train now, you don't have a specific background. I'd take somebody who's keen and interested to learn over somebody, old and jaded who has no interest in doing it. Because the young, keen people, not necessarily young, I didn't mean to be ageist there. The keen people are the ones, you can teach them to use GPR. And so that leads to, the fact that over the last 20 years, certainly systems have become much, much easier to use. And
and that's something that I think is important that I want to, kind of stay on for a second is what kind of background, right, somebody have to have 25 years ago versus the background that somebody has to have today to get into utilizing GPR, getting trained up on it, properly. I even remember just from when I began, right, just over 10 years ago, even then, you had to have some sort of, not an expertise, but some sort of formal training, really, to use it very effectively. But probably about that time is when I think there became this shift, right, in the recognition that, no, there's all these other applications for it. There's huge industries, civil engineering, structural engineering, construction, where people may not have a technical background, or they might not have a scientific background, but recognizing that the technology needs to be used on every project that it can be used on. I mean, I'm the biggest proponent, I think, obviously out there. If you can use it on a project, use it, right? If you are unsure if it's going to work, take it off your truck anyway and use it. Take it out of the case and use it. But that shift, I think, to having a technical background at least, or a formal education in not just geophysics, but in something, and then specializing in geophysics or GPR, versus now where, I had somebody get onto our training system yesterday who purchased a GPR outright. Then they started just using it. They're like, well, I kind of am not sure. And I said, well, it's okay. We can get you trained up pretty fast in about 5 hours, right? From zero to knowing something in about 5 hours. And so, and it was, a pretty simplistic system. They only had a few functions on it, but they were using it to basically clear, boreholes. And so, what do you think about that? Number one is what kind of background does somebody need now? And number two is, with this shift, right, in who the user base is, how has the industry kind of accommodated that shift, right? And then specifically, I guess, how has Sensors and Software accommodated that shift to this kind of new user base?
Well, okay, we accommodate it really, and I think the whole industry is accommodated by simplifying both the hardware and the software. And I would actually venture to say that it's been the change in the software that has made the biggest difference. Because once people could program user interfaces, and we could tweak, and we could figure out what works and what doesn't work, and what confuses people and what doesn't confuse people, then that was huge. And so now the user interfaces that we produce on these systems, to work with. And I think GPR has become like a lot of technologies that people expect to be able to use it out of the box. When you pick up your brand new cell phone, you do not read the manual. You just start poking and pressing buttons and see what happens, sort of thing. And GPR is very much the same thing. Like, people expect to turn it on and say, okay, I'll press this button that says start, and I'll see what happens. Yep. And I think we're largely there. We're largely to the point where a lot of these systems are point and shoot. And so, and that really started, if I can plug Sensors and Software, which I'm going to have here, is that for us, that started with the noggin. In the mid-1990s, we realized that, you know what, our customers are universities, they're PhDs, they're research institutes. And if we're going to get this technology in other people's hands, we've got to make it simpler. And that was the start of our noggin product.
Mm-hmm.
The noggin was really based on technology. And the noggin is not an antenna. And we got to emphasize this.
Right.
A noggin is a complete ground penetrating radar system in one box.
Right.
With one cable. And
yeah.
and that's really what started a lot of things for us. So once you had a system that was so simple to use, and you could develop a user interface that was simple to use, then you could start designing systems for a particular industry.
Mm-hmm.
And that's where we started with Conquest. Conquest was specifically for concrete scanning.
Right.
So we could get rid of a lot of the jargon, the geophysics jargon that goes around GPR, and we could start designing a user interface that somebody who is familiar with concrete and the objects you're going to see in concrete and cutting tools and that sort of thing is going to be able to use and understand. So in other words, you know, getting rid of recording time window in nanoseconds. Well, why don't you just call it what it is, which is depth, right?
Yeah.
And it was certainly this sort of thing. So
yeah, you bring up a couple good points, and I think, you know, you're right. It has shifted, and I think the shift has gone, you know, it's more of the software and the user interface than anything else. But it also depends on how, I think, sophisticated somebody wants to be, right? And so this kind of unpackage it and start using it. People, like you say, are probably, the manufacturer's getting pretty close to that being the case for ultra simplistic, you know, survey work, right? So is there rebar here? Is there not rebar here? You know, kind of begins to do that. I had somebody who was, so we do coaching also, and I had somebody who was sending me data from an LMX 100 actually, you know, just which everybody is a sensors and software system. They're sending me, you know, JPEGs of LMX 100 data, and they're saying, you know, is this a target? Is it not a target? Is it metal? Is it plastic? Is it, you know, and those kinds of things, right, come with training. And I think what people have is this idea that you don't need it. I can do the simple stuff. But what I think is going to end up happening is, as more and more users begin to utilize this technology in civil engineering and construction, and there is more competition, there's going to have to be a shift towards a more sophisticated user, because the competition is going to get better. And I'll say a second point to that, I think, which you kind of brought up, is, and I think this is where people fall short as well, is just because you get a GPR and you decide, all right, well, I'm going to go into the locating business and I learn how to use GPR, you need to know your own industry as well. So picking up a concrete scanner and going out on projects and starting to, and even trying to get more sophisticated without knowing concrete construction at all, I think becomes a real hazard to the industry and to people and you know, work site safety. And people who are in construction should still know construction, right? People who are doing utility locating should still know, you know, utility locate, you know, engineering at least a little bit. People doing archaeology or forensics, right, should know something about archaeology. I think we see this all the time as people begin to cross over now. Okay, well, I do utility work, I'm going to start locating graves. Easy.
Right.
But they should also begin to get versed in that kind of information. You know, and I don't know if too many people are doing that. You know, kind of what do you think?
I agree with you wholeheartedly, actually. And I mean, if I made it sound like these things are so easy to, you know, turn them on and push them, but
well, they're much easier than they were. I mean, there's no question about it. You can unfold the thing, press start, you know, power button, it comes up. You can literally push it and start seeing, like with an LMX, for example. I mean, you can start seeing. So it's not too far off, but
yeah, data collection is dead easy now. I mean, as I always say, if you can cut your lawn, you can be a GPR operator. But really, the number one thing that people struggle with is the interpretation, right?
Yeah.
And as much as you can train people to tell them to look for hyperbolas and look for patterns in the data, and use depth slices and, you know, all the fancy stuff we can do, 3D views, to help them try to understand what's going on in the subsurface. in the back of their mind, they're always thinking, well, what if I miss something? What if I make a mistake? What are the consequences? And as a result, they don't really want to adopt the technology because there's a fear of failure.
Yeah. No, that's a very good point. Yep. So it kind of brings to the next question then, right? Are these accommodations good, for the industries? Is kind of simplifying the data collection technology, simplifying the user interfaces, and broadening it out. So in a sense, almost, anybody can actually utilize GPR now. Is that good? Or good, but what do we have to make sure people do in order to be effective, use the technology properly and not, in a sense, give everybody a bad name, by over-promising, under-delivering, kind of, acting like an expert. People call themselves experts. It's like expert is like air now, right? It can breathe air, like I'm an expert, and people, I'm telling you, the GPR world kind of walk around like that. And I think it could potentially be, but I don't think.
It's been like that. It's been like that my entire career.
So it's not just now, I'm just starting to see it, you're saying.
No, we've always had the charlatans, right? And I think you're going to have that. You're going to have that. And, I use charlatans because I think in some situations there were people who are actually scientifically trained who hoodwinked people, who used a bunch of scientific jargon and said, GPR could do things it really couldn't do. And, they made a lot of money and then, disappeared and gave the industry a bad name. And we've been trying to clean that sort of stuff up. And I don't think you're ever going to eliminate that. I think, it becomes a buyer beware sort of situation. If you're hiring somebody to do GPR work, do your homework.
Right.
Get recommendations. Ask them where they've been trained, and
Unfortunately, there won't be too many buyers, I think, watching this web feed, this live stream. It should be put out to more buyers, but I think you're absolutely right. So where are we going, in the future? Obviously, GPR's come a long way, right? From cassette tapes to iOmega, which I thought was even old school, right? To now, where it's literally wireless and you can transfer images to your phone in the field with kind of basic reporting, that you can give to somebody. Super cool, developments. Where are we going, do you think, in the future? Like, what can we expect in the next 5, 10, 20 years, right? So kind of what's on the short-term horizon, what's on the longer-term horizon? What can we expect from manufacturers?
Okay, here's what I think. I mean, I gotta say, this is my opinion on things, just kind of watching things happen. I think the two biggest impacts for GPR over the next few years are going to be robotics, combining GPRs with robotics, which you're already seeing that. And that includes drones. I think you and I had discussions about drones before, and it's a very natural thing to put an instrument on where it needs to go. So I see that being something. Although technically speaking, I should point out that violates FCC regulations, but that's an entirely other topic. The other thing, so I see robotics and I see the machine learning or artificial intelligence or whatever you want to call it. And because if you think about robotics, think about having a GPR system that could crawl all over a surface or a structure and generate a 3D view of the current state of that structure. Anything, roads, bridges, dams, buildings, inside pipes under the ground sort of thing. And these sorts of images are going to be the ones that help people make decisions, right? Help them make good decisions based on when does a structure need to be refurbished or maintained, or what are we going to spend dollars on it? And that, to me, I mean, the big area we think is happening is infrastructure, right? Dollars to go around, so people have to prioritize. And do you prioritize by saying, well, this is the oldest bridge and therefore we'll work on it first? Or do you prioritize scientifically by saying, we did a scan of this bridge and we have some scientific data here which says it's in pretty good shape even though it's old, and maybe we should go on to another bridge, sort of thing. And that's where we see GPR fitting in, and robotics being part of that. The other thing mentioned is artificial intelligence. So the number one barrier, like people who get into the technology, as I mentioned before, the number one barrier about GPR not being more widely adopted is that the data needs to be interpreted. Mm-hmm. And that scares people. Yep. Right? I get a lot of people who come to our classes who say, yeah, I know how to operate the equipment. I just don't know what these squiggly lines on the screen mean. Mm-hmm. And that's what I'm here for. I'm here to learn about that, the interpretation. And you teach them as much as you can and everything, but when it comes down to it, there's still, I mean, you mentioned that with people who contact you. Is that a target? Is that a target or not? You know, what should I do? I'm calling on you because you're an expert. And so that's a big barrier. And so think about when our machines are smart enough to interpret the data for us. Yeah. And look for these things for us. I mean, that's going to be huge.
Yeah, you know, I did a video about this a little while back. I forget the exact title of it, but everybody here certainly search around YouTube. It's something, you know, along the lines of, you know, should you do automated anomaly detection, right? Should you use automated anomaly detection, you know, in post, you know, processing softwares and things like that. And from what I've seen, I think there's still quite a ways to go, right, before it's really accurate. What I have seen is I found that layering, right, so using it to identify interfaces, geological layers, horizontal layers, has worked out better than trying to find smaller individual kind of point targets. Sometimes it works a little bit better, I found, in kind of rebar, you know, detection, again, that happens to be embedded in a very contrastive material in concrete. But a lot of times I'll do it just to see what happens. And you know, I get things that are picked out as being targets that clearly are not targets, and I get plenty of targets that are left alone. So there's really a little bit of ways to go. And what I kind of concluded in that video was, I don't know if, at least at some, maybe 20 years from now, but certainly over the next 20 years at least, is there's going to have to be, I think, a combination, right? There's clear benefit to artificial intelligence. First of all, it can rapidly, you know, it can decrease project time, right? Okay, you press a button and wham, even if it's only 80% accurate, right? 80% for 5 minutes worth of computer processing or 5 seconds worth of computer processing is a huge benefit. However, I think there's going to have to be a meshing of computer, you know, artificial intelligence and human intelligence, right? So, you know, to check, double check, if it's only 80%, look, when we're talking about hitting gas pipes, like, you don't want to be 80%, right? You want to be 120% sure, you know, if you can, but certainly as sure as you can be. And I pointed out, you know, I'd read a book at the time, and it kind of hit me with PayPal. You know, PayPal said that they tried to automate all of their systems, and they kept getting, you know, basically like fraudulent charges, like every day. And they recognized that, okay, there were a series that could be kind of like identified through automation, but a handful of, you know, and an easy system in order to kind of recheck those by actual humans who can tell whether it's fraudulent or not, right? And so they kind of, even a PayPal had to combine it. And so I think that's, at least in the near term, where it's going to have to go. You know, what do you think about that? Or do you think that that I'm off, and sooner than later it's actually going to be all on?
No, you're bang on. This is going to take a while.
Yeah.
So okay, that's better now. I look at it sort of like, I mean, this might be an extreme case, but think of air traffic control software, right? And I remember talking to one of my friends who's actually an air traffic controller, and he said that, you know, they were using pretty much ancient software for a long period of time because it worked. Yeah. Right? Even though it's 20 years out of date, sort of thing, it worked. And the problem with bringing on new technology is you got to test it for every possible case. And I mean, it's not like something that, okay, my computer crashed, no big deal. We're talking air traffic control. So if something goes wrong, it could be catastrophic and lives could be lost, sort of thing. So you have to make sure it's absolutely perfect. And I certainly see an equivalency there, that there's going to be human intervention for quite a period of time in GPR data. I think you're right. We're 20 years away before I can really comfortably say what a computer tells me.
Mm-hmm. Yeah, I agree. I think people, don't rely on the software. Don't overly rely on automated, anomaly detection. You still have to get trained. I think you still got to get trained in data collection and proper data collection. I mean, I get people who don't recognize that you can back the thing up and it'll move back a marker so you can get over the peak of your anomaly. Because they say, well, where exactly is it? I see this kind of hyperbola. So even down to that level, people who are just taking it out of the box, they can be proficient with a pretty, again, with a 1 day, 2 day course, they can get reasonably proficient at a basic level. But I think people need to continue to learn and continue to grow to be, professionals, right? To be real practitioners of GPR technology. I think people need to continue to learn as well. So you touched on one other thing that I swear I get this question multiple times a week about drones. I got it on a podcast that I did, and I think I gave it like a reasonably incorrect answer, which is okay because it's certainly not the first time that I've been wrong. But I was talking about that. I feel like, again, as a practitioner, right? So not from the manufacturer side, but as a user, I always felt like the things that can influence the GPR are dramatic. Now, again, the shielding has gotten a lot better. The data has become more clear. But I've always felt, at least with the drones, that you just have to be careful with kind of the, electronics and the interference and whatever else is going on. But like you said, but it is coming. Is it purely kind of an FCC issue, or is there anything else that is a problem? I mean, I've gotten people who are like, reach out to me to say, I have this idea. I don't know if anybody's thought about it yet. Have you thought about putting a GPR on a drone so you don't have to do it? And I was like, I promise you, I love you, but you're not all that unique. Okay, with this idea. And so, so is it just the FCC regulations? Because that was kind of a big wow to me. And I'm not sure if everybody out there, who's watching and listening knows that there are regulations that limit what can be produced in the U.S., I think Canada also, that are not limits to elsewhere in the world. And so you can go elsewhere and potentially get different antenna that are much lower frequency, much higher power, that may actually still not go as deep as you want, right? One thing that you were telling me is that you can maximize the power out by 100 times and you're only going to get 20%, or return in depth or something like that. You have to increase a lot of power to get a little bit of benefit. With the drones themselves, is there other issues that are holding this back, and what would have to be done to bring it to market?
I think it needs to be a really good application that will drive it, and then the economics will drive it from there. And one that certainly comes to mind is being able to deploy systems in remote areas for whatever reason.
Yeah.
I know we have customers who actually all around the world who one of the big issues right now is water.
Yep.
And being able to know your reservoir going to be based on the melt of the snow from the previous winter. And they'll go out with skidoos and they'll drive around hundreds of kilometers to measure amounts of snow so that they can do volumetric calculations of how much water they're going to have in their reservoir. And think about being able to send out an army of GPR drones to go out and do the exact same measurement. I mean, it's very natural. Now, I don't think the economics has reached there yet. Right. But you are going to have some application like that people will be willing to pay for.
Yeah. Okay. So then one other question, just to follow it up, because we are coming up on 40 minutes, and I know you have a lot to do, saving the world one GPR at a time. And so, with the development of drones, the manufacturing of drones, and being able to put GPR on it, that clearly has an effect on the data's response, right, on the response, on the signal response, as opposed to
maybe not clearly. I mean, that's something to be tested for, and that's a pretty darn simple test. Is drone putting out frequencies that we're going to pick up on our receiver, and And if we're out of the band, then, you know, we may not have issues at all. I mean, certainly it's the same sort of thing as running a GPS on top of your system, right?
No. Okay, so what I was saying was it being air coupled versus ground coupled. You know, and what's going to be the effect of that for different applications, right? I mean,
absolutely.
It clearly would be different, I guess, if you're looking for massive reservoirs versus if you have the locator guy, right, who's just trying to find the stuff and try to do, you know, maybe less work, be out less in the sun. Is the quality of the data going to be impacted on kind of near surface, you know, projects like a utility locating or, you know, or archaeology or something like that?
Oh, dramatically. It's a pretty simple test to see what happens when you raise your GPR off the ground. And the amount of energy that gets into the ground goes down dramatically. I mean, you go from, by the time you raise it up like half a wavelength or something off the ground, you're losing 75 to 80% of the energy. And so around and survey, it's tough. You have to be in really good conditions. You have to be in a very sandy environment or a very electrically resistive environment before you can send signals from the air, penetrate into the ground, come back out of the ground, go through the air, and come back up to, you know, the receiver. That's a very challenging path. Yeah. And there's not many applications that that's going to work for.
Yeah, and I say that to people all the time, but I wanted to make sure that I got you on record here, okay? The manufacturers themselves, okay, confirming it. And so, you know, even with basic utility locating, even if you have, you know, a push cart system, keep contact with the ground with your antenna when you can. You're going to be better off. You're going to get a lot more energy into the surface, and ultimately you're going to have a better data. So any kind of closing words, you know, for the Learn GPR community, you know, that you want to say?
Well, I want to tell the story that I told you during the course when you were up here, and it's funny and a sad story, but it fits into exactly what you were saying was training. And that was the fact that I got a call one day from a very irate rental customer. And when I got him to calm down and I got him to send the data, he said, you know, your system, let's just say he wasn't too complimentary about our system because it found something for him. So the story is that it found something for him. He, in a remote place, he found a hyperbolic response in a remote area. He paid somebody $10,000 to bring a backhoe into that area, and he dug down, and there was nothing there. And as a result, he called me, and we had a discussion, and he sent me data. And what it resulted in was that when I looked at his data, it was actually an airwave. It was an airwave hyperbolic response. So something had reflected, the energy had reflected from something nearby, and he thought it was in ground. And
so a cautionary tale.
That, you know, no matter how good it is out of the box, a little bit of training, at least a little bit of training, can go a long way. And in this particular case, it would have saved him 10 grand.
Yeah, $10,000 way. So, yeah, well, it's such a great story, a sad story for the gentleman, but a great, you know, kind of cautionary tale, I think, for everybody. Same thing, we recently did a video on this about, you know, kind of false positives in your data, and they're not false. The truth is they're not false positives, they're real positives, they're just not below the surface. And so recognizing kind of how the system works, how it's producing energy, where that energy goes, and what can actually make it back to your antenna, which might be something that never even came from your antenna in the first place, is critical. But that was a great one. I mean, I love that story too, because it's just so powerful that this is it's real, right? It's real, and people need to, like you say, a little bit of training, and which is kind of our mantra, right? You don't need to be, this is what I say, you don't need to be a PhD to use a GPR. Okay, you don't need to be a PhD to use a GPR, but, you know, a day or 2 days or 3 days of training makes you dramatically better, dramatically more cautious, dramatically more aware of the limitations, dramatically better at communicating with your clients, your customers, and ultimately makes you a better practitioner, a better professional. And so I agree with you. I think it was a good ending story. So Greg, thank you so much. I really appreciate it. Anybody who had stayed on for this entire time, because there are some folks that are still watching, thank you guys so much. Really appreciate it. I'll tell you what, I'm going to do a little contest here, okay, in the name of Sensors and Software, and to thank Greg, is we do coaching. Like I said, we charge, by the hour for coaching. I will give somebody a free hour of coaching. If maybe nobody steps up and does it, maybe you're the only one and you just automatically win the coaching. But if you tweet out to me at @LearnGPR, if you tweet out GPR was recorded with cassettes, I will give you, and you win, and subscribe to the YouTube channel. You have to be a subscriber to the YouTube channel and tweet to @LearnGPR. GPR was recorded with cassettes. I will give you a free hour of coaching. That's $250 worth. That's what we charge for the coaching. So free hour of coaching for subscribing to the channel. Okay, like this video, not part of the contest, but you should like it anyway because Greg was awesome. And tweet @LearnGPR. To tweet at me @LearnGPR. GPR was recorded with cassettes. All right, well, thank you so much, Greg. Thank you. I really, really appreciate it. I really have valued our interactions over the last several months and, a year. And I appreciate all that Sensors and Software is doing. Super, super innovative company. I think you guys are one of the ones that are accommodating this, this development of the user base, I think more than most, coming out with this interfaces that can just, help people out, make it easy, kind of, if we're trying to get it used on every project it can be used on to increase site safety, right, and protect cultural heritage, engineering, works, civil heritage, and infrastructure, we want it in the hands of as many people as possible. And I think Sensors and Software is leading the field in making sure that it's in the hands of as many people as possible. So I appreciate it. I appreciate you being on here. And everybody tune in next time for, I guess the next episode of the GPR Hot Seat. All right, we'll see you soon.
Okay.